Okay, so 3-5 is solving systems of 3 equations, which means now that we've added another variable. So if you have 3 variables, you have to have 3 equations. If you have 4 variables, you have to have 4 equations. No, we're not going to do that. The most I'm going to give you is 3. Okay? Now, this section right here requires you to have good math skills, meaning a negative times a negative is a positive. A positive times a negative is a negative. Okay? It requires you to remember that 1 times 1 is 1. You can't tell you how many times I saw it was 2 on your test. Okay? So this section requires you to have good Algebra 1 skills, or pre-algebra skills, if you will. If you're not sure, use your calculator. Okay? I'd rather you use your calculator to multiply 2 times 3 than to tell me it's 5. And then we've messed up this whole problem. Okay? So, here we go. To solve a system of 3 equations, you have to use the methods of substitution and elimination. We have to do both. The solution is called an ordered triple. When we were graphing them, we wrote our solution as the ordered pair, x comma y, right? When we were solving them, we just wrote x equals and y equals. Now you can write it as x comma y comma z, or you can just say x equals y equals z equals. I'm okay with either one. Sometimes it's not x, y, and z. Sometimes it's p, q, and r. Okay? So then you just write them alphabetically. Okay, look at this guy right here. Number 1. Like I said, when we add a variable, we have to add an equation. So I have 5x plus 3y plus 2z equals 2. 2x plus y minus z equals 5. And x plus 4y plus 2z equals 16. Now, before you start, you need a game plan. We're going to work with groups of 2 equations at a time. And we have to get rid of 1 variable from both sets of equations. So I need a game plan. I need to look at this guy and say, okay, who is the easiest one to get rid of? You have to do elimination first. So what variable looks like it might be the easiest to get rid of? Z, right? Z is pretty nice. I've got a 2z, a negative z, and a 2z. So if I just multiply this guy by 2, he'd be easy to get rid of, right? Alright, so I'm going to do that. But I'm going to work with groups of 2 equations at a time. So I'm going to work with the first 2 first. Now, this homework also requires lots and lots and lots of paper. Now I'm going to multiply everybody by 2. So I get 4x plus 2y minus 2z is equal to 10. Another thing I see a ton of on these guys is you forget to multiply the constant by the number out front. So remember to distribute to everybody. And let's add these 2 guys together. So I get 9x plus 5y. The z's cancel, is equal to 12. Circle it. We're going to have to come find it here in a minute. So circle it so you can find it. Okay, so I ignored that bottom equation completely. I just grabbed the top 2 equations, I multiplied it by 2, and I got rid of the z. You have to get rid of the z again. So once you decide you're going to get rid of z, we're going to work with another set of 2 equations and get rid of z again. You can work with the top and the bottom, or you could work with the bottom two. I'm just going to work with the bottom two. And again, I need that guy to be multiplied by 2. So 4x plus 2y minus 2z is equal to 10. And 1x plus 4y plus 2z is equal to 16.
So
We can, but I have to get rid of the z again. So there's two things you can do, JJ. We can work with these two, and I'd have to multiply by 2 again to get rid of the z. I could have also worked with the top one and the bottom one and gotten rid of z by changing the signs of all the second one. Does that make sense?
Yeah.
So there's two options you can do. It's really up to you.
Okay. So you have to keep the multiplication that you did in the last problem is the second problem.
Not necessarily. This one just works out that I need it to be a 2. If this guy were a 3, then I would have done a 3 instead. Like I have to get rid of the z though. Does that make sense?
Yeah.
So since I got rid of the z here, I had to get rid of the z between these two. So like I said, if this would have been a 3, then we would have done a 3 instead. You don't have to do the same multiplication.
Okay. Yeah.
Good question. Okay, I'm going to add those two guys together. 4x plus 1x is 5x. 2y plus 4y is 6y. The z's canceled like I wanted them to. And I get 26. Circle it. Look at what we have there. What do I circle? I have two equations circled, right? How many variables do they have? 2, right? Isn't that what you were just doing last week in 3-1? 2 equations with 2 variables. Okay, we're going to do it again. So now I'm going to work with these 2 equations. 9x plus 5y equals 12. And 5x plus 6y equals 26. Now, the thing is, numbers probably get big now, and that's okay. But we've got to do it again. This guy's not really nice for a substitution problem, is he? Now, so let's go to elimination. What would you like to eliminate, x or y? And it's totally up to you at this point. X? You bet, China. Okay, if I'm going to get rid of x, what should I multiply the top guy by? 5, right? We do the coefficient of the other guy, so we're going to do 5. What should I multiply that guy by?
Negative x or negative 9.
Yeah, and I'm going to do negative 9. Perfect, JJ. I'm going to do negative 9 so that I can add, because subtraction sucks. I hate to say it, but I hate subtracting. Okay? That poor little minus sign, I hate him. Now, this is like I said, your numbers are going to get big, and that's okay. You got a calculator. Use it. I'm going to distribute a 5 to everybody. So I have 45x plus 25y is equal to 60. This is probably the one where I'm going to need my calculator because I have no idea what 26 times 9 is. Negative 45x minus 54y is equal to... Awesome, thank you. Negative 234. Oy, I gotta zoom out. Sorry, guys. Okay, 45s are going to cancel. The x's are going to cancel. And I have 25 minus 54. Did you have a question, JJ?
Oh, that's funny. For whatever reason, I had my mic unmuted, and then I muted it to talk.
Technical difficulties.
I was saying -29.
Oh, awesome. And then I have negative 234 plus 60, or 60 plus a negative 234. Divide by negative 29. Hey, look at that. It worked out nicely. I will guarantee you on your homework they work out nicely. Okay? You shouldn't get crazy decimals, no crazy fractions. I promise you they work out. They will also work out on your test. Okie dokie. So if you got something like 5.4, stop and ask for help. Okay, go back and check and make sure you've multiplied everything correctly. Okay, so I got y equals 6. Am I done? No. What do I have to do now? I have to plug it in, right? I still have to find x and z. So, remember I said we're going to circle them? That's because we have to find them again, because now we're going to use one of these two guys to find x. Does it matter which one? No, you get to pick. I might... Which one do you want to use? I don't care. The bottom one. Okay, this one's numbers are a little bit smaller. That's what I was going to say, Shrina. So now I'm going to plug this guy into there. So 5x plus 6 times 6 equals 26. Like I said, I circled them so I could find them again. Put a box around them, highlight them, something, I don't care. But that way you can find them. All right, 5x plus 36 is equal to 26. And I'm going to subtract 36, so I get a negative 10. Negative 10 divided by...
Are we going to have all the room we need to do all that stuff on the homework?
On your homework, it's slammed together a little bit. You might be able to do some of it, so you might need some extra paper. Yeah. Okay, are we done yet? No. It's like the problem that never ends, right? So I've got x, I've got y. How do I find z? Plug both of those guys into any one of the 3 printed ones. Okay? Any preference on which one we use?
The middle one.
Okay, let's do the middle one. The numbers are nice and small, right? They don't have a lot of coefficients. I like it. So I'm going to go to the middle one before I multiply by anything. So I'm going to say 2x plus y minus z equals 5. And now I'm going to plug in negative 2 for x, 6 for y, negative 4 plus 6 minus z equals 5. 2 minus z equals 5. Be careful, that's a negative z, so keep his negative with him. So negative z is 3, so what's z? Negative 3. If you leave it right like that, that's perfectly fine. If you want to write it as a triple, we just go in alphabetical order. So x, y, z. Like I said, you can leave it like this, or you can write it as your triple. I'm good with either. Okay, questions? It's a lot, right? You have to get rid of the same variable twice. So we got rid of the z's here. So we have to get rid of the z's again. If you don't, you're going to get stuck. Then we worked with these two equations. Got rid of another variable. You can substitute or eliminate there. It just depends on how it works out. Get down to 1. We circled them so we could find them again. Plug it in. Then get both of those and go back to an original and find the third one. Like I said, on your homework and on your test, they all work out nicely. Okay, so there's no decimals, no crazy fractions. So that's a good, like, oh crap, I got something with a decimal. I got 5.2. What did I do wrong? Okay? All right, let's try another one. Number 2. Hint, hint, wink, wink. This one's on your homework worksheet. So, you should get at least one of your homework ones right. Okay, number 2 here says, solve the system of equations, and then it says, hint, line up the variables. Well, how many variables do we have? 3. We've got P, we've got Q, and we've got R, right? But does every equation have all the variables? No, it doesn't. So I'm going to line up the variables. So watch what happens when I line up just these two. So I'm going to work with the top two. I have P, Q, and R. All right, so I have 1P. This guy doesn't have any Q, so I'm going to put a 0 placeholder in. That's what it means by line up the variables. Put in a placeholder. And then the bottom guy doesn't have any R's, so I'm going to put a 0R in. What's the only variable I can get rid of in that equation? Or those two equations, I should say. P, right? That's the only one they have in common. I have to get rid of the P. I can't multiply by 0 because it makes the whole equation go away. So the only choice for me to get rid of is the P. All right, now like I said, subtraction sucks. So I'm going to flip, 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 and add. Now it's 0R, but that doesn't change anything. Now why do I say that subtraction sucks? Because you'll subtract these guys, you'll remember to subtract those guys, but when you get all the way down here, then we forget. That makes sense? So use addition as much as possible. All right, so my P's are going to cancel. Then I'm left with 3Q plus 4R is equal to 1. Circle it. What do you notice about our originals? I have an equation here with Q and R in it. Is there an equation over here with just Q and R in it? The bottom one, right? Yeah. Half our work's done for us. We just need two equations with the same two variables. So the nice thing about a variable missing is sometimes half the work's done for us. All right, now I have these two equations, and I've got to work with these two. So I have 3Q plus 4R equals 1, and Q plus R equals 1. What do you want to do now? You want to do, did you say elimination, China? What would you like to eliminate? Okay. If we get rid of Q, what would you like to multiply by? Awesome. Thank you, Shayna. So I have 3Q plus 4R is equal to 1, negative 3Q. Sorry, my Q's get a little crazy. minus 3r is equal to a negative 3. So I have a positive 3q and a negative 3q. Those guys are going to cancel. A positive 4r plus a negative 3r gives me a 1r. And 2 plus a negative 3 gives me a negative 2. We've got 1 done. Okay, now what? Plug it back in, right? Grab one of your circle ones. Does it matter which one? No, I'm going to go to this guy because he's smaller numbers. If you go to that one, does it matter? No, you should still end up with the same thing. So I have q plus a negative 2 is equal to 1. So q equals 3. Now we just have to pick an equation with a p in it. The second one? You got it. P minus 3 times q equals a negative 8. P minus 3 times 3 is equal to a negative 8. P minus 9 is negative 8, so I'm going to add 9. So P is 1. So P is 1, Q is 3, R is negative 2. Like I said, hint, hint, wink, wink, it's on your worksheet. Hold on 1 second, Abigail. Let me turn you up so I can hear you. Okay, say it again.
It doesn't matter what order you put them in if it's not specifically X, Y, and Z.
Just do it in alphabetical order. So P, Q, R. Oh, you can't see it. I'm sorry. P, Q, and then R. So go alphabetical if it's not X, Y, Z. Good question. Thank you.
That part up there, I was like still trying to figure out the first part I looked up and it's all done.
You're welcome. Okay, where are you stuck? You want me to, here, I'll just explain what we did. Does that sound good?
Yeah.
Okay, so what we did is we worked with the top two equations, and the only variable that they have in common is the p, so we had to get rid of the p. The top equation didn't have a q, so I gave it a 0 coefficient, and the bottom equation, or the middle one if you will, didn't have an r, so I gave him a 0 coefficient. So I added those two guys together and got rid of the p's because that was the only one they had in common. So I got an equation with a q and an r in it. They gave me an equation with just a q and an r in it, so I didn't have to do it again. I could just work with the one that they gave me.
Yeah.
So then I worked with those two and I decided to get rid of the q's. So I multiplied the bottom equation by a negative 3 so that the q's would eliminate. So I got r equals 2, negative 2. And then I went back to one of the ones that I circled. This guy had smaller coefficients, so I decided to use him. That's the down here. So I got q is 3. And then pick one of your top two equations. I did the top one, or sorry, the middle one, to find p by placing in q. You could have also found p by doing the top equation and putting r in. So we found p is 1. So I got 1, 3, negative 2. And then if you're going to write them as an ordered triple, you just write it in alphabetical order. Is that better, JJ?
Yeah.
Okay. I'll leave it there so you can copy it down, and then we'll start talking about the next one. Any questions so far? Okay, number 3 says solve the system of equations. Let's make a game plan. What do you think? What looks like the easiest variable to get rid of? And we remember we have to get rid of that variable twice. It's totally up to you guys.
X, because it's all multiples of 3.
They're all multiples of 3, so let's go ahead and try to get rid of x. I'm good with that. Okay, so if I work with the top two, what should I do? Multiply the top one by 2. Okay, let's do it. And I'm going to do a negative 2 so that I can add them. So I get negative 6x plus 2y plus 4z is equal to a negative 8. So then I have 6x plus 4y plus 8z equals 11. Okay, when I add them together, my x's are going to cancel, so I get 6y plus 12z equals 3. Circle it. Okay, now, it's up to you which two other equations you use. We could do the top one and the bottom one, or we could do the bottom two. Let's do the top and the bottom. I agree, okay. Let's do the top and the bottom. When I do the top and the bottom, what do I need to multiply instead of negative 2 now? Negative 3. So I'm going to multiply now by negative 3. So I get negative 9x plus 3y the plus 6z is equal to a negative 12. Negative, positive, positive, negative. Yep. So the x's cancel. I get 9y plus 18z equals a negative 15. Circle it. So I have 6y plus 12z equals 3, and 9y plus 18z equals a negative 15. So now we have a choice. We can get rid of the y, or we can get rid of the z. The y's are a little smaller, right? The coefficients are a little smaller. What number could I make the y and the z to? David? No, Thomas.
Okay. So turn the y's both into
Yeah, we could turn them both into an 18, right? We don't have to make them super big like 54. We don't have to pick 9 for this guy and 6 for that guy. We both know that we could make them into an 18. So I'm going to multiply the top guy by 3 and the bottom guy by a -2. If you do go to 54, that's perfectly fine. You're just making them bigger. That's okay. So I get 18y plus 36z is equal to 9. And negative 18y minus 36z is equal to 30. Uh-oh. What's going to happen?
It's going to be 0 equals 39.
Yeah, we get 0 equals 39. Does 0 ever equal 39? No. Now, look at how far it took us to get a no solution. That kind of sucks, right? It looks like everything's going great, but as soon as you get a 0 equals 39, that means, or whatever, it means something's not going to work. 2 of them may meet, but the third one won't. Okay? Yeah.
Looking back, I can now see that if you multiply the middle solution, the middle equation by 1.5, it equals to the exact thing as the bottom solution.
Yeah, you're exactly right. Like if you look at those two, we might have gotten it sooner, right? So yeah, if you see something that looks, hey, that looks kind of like a pattern, or is there something I could do? And you see that either they're the same line or they're not going to work or something's going to cancel out, do that. Okay, so as soon as you get something like 0 equals 39, 0 equals 4, then you can stop. Okay? All right, questions on 3 by 3s. 3 equations with 3 unknowns. Okay, let's look at your worksheets so I can give you some direction on that. I'm going to stop this.